In the last two examples, there was sort of an obvious choice, especially once you get more comfortable with this method, to multiply one of the equations by a particular value so that we could get one of the variables to cancel out. In example 11, it's not quite as obvious. There's no easy step where we can multiply one equation by a value, or at least by an integer, and get one of the variables to cancel out. So what we'll have to do in this case is actually multiply both equations by some value in order to get to that desired result. We can look at either eliminating x or y. In this case, we're going to eliminate the x variable. And to do that, we're going to take the first equation times -3, and we're going to take the second equation times -4. I'm sorry, times +4 to make sure those signs are opposite. Because what's going to happen is our coefficient for x will become +12 in equation 1 and -12 in equation 2. So we're multiplying by something specific to make sure those coefficients end up being opposites of each other, so that when we add them together, they'll cancel out. So again, here we're going to end up with +12x minus 6y is equal to +66, and -12x plus 20y is equal to -136. Again, it can take some thought to determine what our best choice is, but in this case, multiplying the first equation by -3 gives us +12x. The second equation by +4 gives us -12x, so that those will cancel, and we'll be left with 14y is equal to -70. And dividing both sides by 14 will give us y is equal to -5. If we take that result and plug it into equation 2, we'll have -3x plus 5 times -5 is equal to -34, which will be -3x minus 25 is equal to -34. If we add 25 to both sides, we'll get -3x is equal to -9, and then dividing both sides by -3 will give us x is equal to 3. Meaning our solution will be the coordinate pair +3, -5. In example 12, our best choice might actually be to use the substitution method, since one of our equations is already solved for y. But we're going to go ahead and still solve this using elimination, just to demonstrate that we can use either method. So if you have one that you prefer once you get some practice with these, I do encourage you to try both. But in the end, they're both work equally well. It just kind of depends. There are scenarios where one might work better or have fewer steps. But what we can do is, in example 12, take equation 2 and add 3/5 x to the other side to rewrite this as 3/5 x plus y equals -2. So all we've done is rewritten this in standard form, having x and y on the same side of the equation. If we wanted to take this even one step further, just to make our process a little bit easier, we could get rid of this fraction by multiplying both sides of this equation by 5. This will leave us with 3x plus 5y equals -10. So all of that work was just taking that second equation and rewriting it in standard form so that now we can use this elimination process to solve this system. Substitution would have also worked, and again, we're just demonstrating that both methods are valid. In order to get one of our variables to cancel out by adding these together, we'll multiply our first equation on both sides by -3, and we'll multiply equation 2 on both sides by 2. This will give us -6x minus 12y is equal to 30. And 6x plus 10y is equal to negative 20. Now 6x and negative 6x will cancel with each other, leaving us with negative 2y is equal to 10. And we end up with y is equal to negative 5. Then going back to either of our original two equations, in this case, if we plug y equals negative 5 back into equation 1, we would get 2x plus 4 times negative 5 is equal to negative 10. And solving that through our same processes would give us x equals 5. So we get the coordinate pair 5 comma negative 5. Again, as you work through these, try both methods. If there's one that you prefer over the other, you can always just use one method. Sometimes it requires a little bit more work, like we had to do to equation 2 in this case, to rewrite this in standard form. But both methods will work to solve a system of equations.